I'm Anil Kumar, and here is question number 2 on radian measure and angles on Cartesian plane. The question is, each of the following points lies on the terminal arm of an angle in standard position. Sketch each angle, determine the value of r, the hypotenuse, determine the primary trigonometric ratios, calculate radian value of angle to the nearest 100. So we are given 2 points. Part A is -6 minus 8 and B is 0 minus 7. So let's draw our Cartesian plane and plot the point -6 minus 8. So x value is negative. Let's say this is -6 and -8 will be here, right? So let's say that's our point of interest. So the terminal arm is going to be like this, right? So it says each of the following points lie on a terminal arm of an angle in standard position. So whenever we say standard position, that means initial arm is along the positive x-axis. Okay? And therefore, the angle of interest is this angle, that is the principal angle for us. Okay? And this point is -6 minus 8. That means y value is -8 and the x value is -6, right? So we can sketch each angle like this. So that's the initial arm, right? And these angles have vertex at the origin, right? So that is how you're going to make the angle. Determine the value of r. So r is this length of the arm, which you can find using Pythagorean theorem. So if I drop a perpendicular here, I know this length is 8 and this length is 6, right? As far as lengths are concerned, we have to take positive. So r, the length of the arm, is, we can use r equals to -6 square plus -8 square root. So which is 36 plus 64 square root, which is equals to 10, and therefore r is equals to 10 for us. Now it says determine the primary trigonometric ratios. Now whenever we are talking about primary trigonometric ratios, that means sine, cosine and tan, right? So let me write down here sine, cosine and tan for the angle theta. Let's say this angle is theta, right? So sine theta will be equals to, now since we are in this quadrant, which is quadrant 3, let's write down the cast rule also, which will help us to find the sine. So cast rule is CAST. So only tan is positive in quadrant 3, rest primary trigonometric ratios are negative. Sine is opposite side over hypotenuse, which is -6, you can clearly see. So it is -6 over 10, which could be simplified as -305. Correct? Cos theta will also be negative, as you can see. Adjacent side for cos is -6. Sorry, this was sine was opposite side, which was -8. Let me correct it. So it is sine is -8. When you divide by 2, we get -4 over 5. Cos is the adjacent, this is the adjacent side, right? Which is -6 over hypotenuse of 10, that gives you a value of -3 over 5. Tan theta is equal to, so we can look into this alpha itself, opposite side, which is -8, this is -8 and this is -6, right? So tan theta is -8 divided by -6. Right? So when you divide by 2, both of them, you get 4 over 3. So that is the value of tan theta. As you can clearly see, tan is positive, sine and cosine are negative. So that is how you can do it. Now let's look into part B. Here we have taken coordinate point 0, -7. Okay, so let me sketch it here. 0 minus 7 means x value is 0 and y value is -7. So that becomes -7 for us. So we have this kind of a triangle where r is minus 7, right? Now the angle here is pi by 2, 2 pi by 2, 3 pi by 2. Theta, the primary angle, is 3 pi by 2. Correct? Now, for this particular angle, you can think about a triangle with opposite side as equal to, if you see angle of 90 degrees, your base is 0, right? The opposite side and the hypotenuse are same, correct? So sine theta will be equals to 1, but with negative sign. So it is minus sign, r is minus sign. The opposite side, I could say opposite side is equals to minus 7 and adjacent side equals to 0. This base is 0 for us. Do you see that? So sine is, you remember the SOHCAHTOA rule. Let me write that also. Sine is opposite over hypotenuse. Cos is adjacent over hypotenuse. And tan is opposite over adjacent. That's why I'm using these. Right? So in this particular triangle, think about a triangle. Let me just make this dotted here just to show you. Exactly this dotted line is on blue line, right? So the radius and the opposite side both are minus 7, but the base is 0. That is, the adjacent side is 0. So for sine, what we get here is, well, r is always positive, never negative, right? So that was a mistake. R is always positive. So sine theta will be opposite side of minus 7 divided by 7, which is minus 1. Cos theta will be equals to adjacent, which is 0, 0 over 7, which is 0. And tan of theta will be equals to opposite over adjacent, right? So opposite side is minus 7 and adjacent side is 0. So that is undefined. So that is how you can get these values. My recommendation is that whenever you're dealing with 0 or 90 or pi by 2, you should actually see how the function behaves. Sine theta, for example, is a function which is like this. So as you can see, it is 0 at these 3 points, which are 0, pi and 2 pi. As far as cos is concerned, for cos, the function is kind of like this, which is 0 at pi by 2 and at 3 pi by 2. At pi, it is minus 1, right? At 0, it is 1, and at 2 pi also it is 1, correct? But the zeros are at pi by 2 and 3 pi by 2 for cos, correct? So 3 pi by 2 is the angle which you are dealing with. So cos is 0. So you could use these angles for such cases, right? And tan theta is the ratio of sine over cos. Perfect. So that helps. So in this case, r is 7 for us. This dotted line is r, which is positive 7. Opposite side is minus 7. Adjacent side is 0. I hope that helps, right? So for solving such questions, you should know SOHCAHTOA, which gives you trigonometric ratios. The cast rule, right, which tells you in which quadrant which trigonometric ratio is positive. And you can use the Pythagorean theorem to find the radius. I hope that helps. Thank you.